Hello everyone, this is Singh Shekhawat and today we will be discussing fourth chapter of designing data intensive application, which is encoding and evolution. We will try to extract out the important points and try to discuss how can you evolve your systems and encode your systems. So let's start into it. तो अगर हम basic description की बात करें, like what is the basic gist of the chapter we will be discussing today, what's that? So you let's say you start your application, you are owning a startup, right? You are owning a startup, you created some application. Let's say you have application of cab booking, right? So initially you only had 10 customers. Now as and while your application became popular, as and while your cab booking application became popular, more and more customers start to coming up, right? And there were like more requests. Let's say initially you were only providing a single cab booking, right? A single customer can book a single cab. Then you also provided a feature for cab sharing, right? Now it could also be possible that in cab sharing as well you added and enhanced the feature. So how will your architecture evolve? How will your the data models you defined, how they will evolve, and how will you ensure that any changes in your system is not impacting the customer? It should be compatible. The new code or the new data models you're defining should be compatible with the older architecture you maintain. So how can you do it? That's the basic gist we are talking about. That's the basic gist that we will try to deep dive into it today. ठीक है, तो ये हमने डिस्कस किया कि न्यू चेंजेस विल, इट्स इनएविटेबल. ठीक है, इट्स नॉट पॉसिबल कि यू कैन डिज़ाइन एप्लीकेशन सिंगल हैंडेडली इन द फर्स्ट प्लेस एंड देन it will work for hundred and hundreds of years. That's not gonna work, right? Your application is gonna evolve and you have to make sure that when it evolves, it do not break and it keep on serving the customers. So first thing will be how will you roll out these changes without breaking the application and continue serving customer. So the most important factor here is when you roll out the changes, you don't roll out the changes for all the customers all together, right? So let's say we mentioned that we are introducing a new feature of cab sharing. Now how will it work? Let's say this is your cloud architecture and you have let's say 10 issue2 machines here. Okay, so you have 10 issue2 machines. Now when the requests come to your backend services, this is your load balancer and the request will be hit to these servers and then it will be served. When what will happen if a customer request is coming up, it will hit to particular server, right? Now when you roll the changes, you will just roll the changes to a single instance first. Let's say my new changes are only applicable on this node. So when request come to this node, the new functionality will be served to the customers. But if request is going to these node or these nodes, then the new functionality will not be reflected. Now how it's helpful? It's helpful in a sense that if any issue appears, it's only affecting the customers, the requests which are coming to this particular server. Pencil चल क्यों नहीं रही? हाँ, this particular server. तो what you are doing, you are reducing the blast radius here. पहले क्या हो रहा कि let's say you have all the 10 machines and you are rolling out the changes to all these 10 machines. What will happen? It will impact all the customers, all the requests which are coming to a server. But if you divide your rollout, the new changes you are making up into your architecture, if you divide that into steps, what you ensure that the blast radius is minimized or like contained, so that your customer experience is not hampered, or if it's hampered, it's only hampered for a reduced set of number. Okay. So what you can do, you will let's say you will first launch this feature on this particular node, then you will increase the nodes to the, let's say now you are serving from 3 nodes right now. Let's say what you can do, let's say your initial 10% traffic was served via this, then you move to 50% traffic. Okay, then you move to 100% traffic. Another use case could another scenario could be that you are rolling out changes basis particular reason. Let's say you kept the cab sharing feature first you roll out in Pune. ठीक है, then you launch it out in BLR Bangalore. ठीक है, then you launch it around Gurgaon. ठीक है. So what you are trying to do, you are trying to contain the changes, you are trying to roll out the changes in a way that it is not impacting your entire set of customers, and you are also checking and also monitoring in there that if any issue comes, it's only impacting a certain set of customer and you can fix on the go. ठीक है? So what you have to ensure for any changes you make in your application, it should be backward compatible, it should be forward compatible. Now when these scenarios come up, what we mean by backward compatible is, backward compatible means that your new code can work with older data. ठीक है, आपने कुछ नया कोड लिखा है and you have already data present in your database. Now the new code you have written, ठीक है, it will fetch some data from this database. Now this can expect some new fields which should be present in data. Let's say this were earlier there were 2 columns and you have introduced column 3 as well in database. Now this new code will expect this, but the older data which is present, it will only have these 2 columns specifically. So how will you handle that? That is called backward compatible. If you talk about forward compatible, your old code can work with newer data. ठीक है, हमने बात करी कि some of the machines will have old code running, some of the machines will have new code running. So you have to ensure both the scenarios कि your application is forward compatible as well as your application is backward compatible. So in case of forward compatible, what we mean that old code can work with newer data. So if there are 3 columns, ठीक है, and the old code expects only 2, how will you ensure that it keeps running smoothly and there are no issues? ऐसा नहीं हो भाई ये एक्स्ट्रा डेटा कहाँ से आया, क्या करें इसका? Application should not break in that case. So we have to ensure that. So we have to ensure that you can roll out the changes in stages, the staged rollout which we mentioned, कैनरी डिप्लॉयमेंट जिसको बोलते हैं. ठीक है, तो दैट्स वन थिंग. अनदर थिंग इज योर कोड इज कंपेटेबल. इट शुड बी बैकवर्ड कंपेटेबल, इट शुड बी फॉरवर्ड कंपेटेबल. ठीक है. नाउ if we talk about how programs work with data, it can be possible that it works in memory. ठीक है, this is your machine and there are processes which are running on this machine which interact among themselves to carry out any क्या बोलते हैं, carry out any of the feature. ठीक है, कोई like you have written some program and there are multiple processes which interact to complete that particular logic in the which is written inside the program. ठीक है, that could be one possibility, that it could use your internal data structures, list, hash maps, any data structures which you have maintained, and it performs the work which you have specified. Another thing could be you send the data over network. ठीक है, now always there will not be a case कि your local machine will be able to serve your use case. Sometimes you have to interact with other machines, other services. Let's say जैसे for example in case of UPI, ठीक है, in case of let's say phone पे application, ठीक है, phone पे hits APIs of government UPI APIs to do the payment processing. ठीक है, तो phone पे is not doing all the logic inside its own data center. It is also hitting some third party, the government APIs, टू डू द ट्रांजेक्शन प्रोसेसिंग. वैसे UPI का हम सिस्टम डिज़ाइन वीडियो बनाएंगे, हाउ इट इज़ डिज़ाइंड. सो स्टे ट्यून्ड एंड वी विल बी बैक विथ इट, बट ये बुक कंप्लीट होने के बाद में. ठीक है. तो इन दैट केस व्हाट यू आर डूइंग, यू आर सेंडिंग द डेटा ओवर नेटवर्क. ठीक है, सो व्हाट यू डू, यू एनकोड इट टू सम डिफरेंट फॉर्मेट, एग्जाम्पल JSON, and then send it. Why we are doing that, we will discuss that in the coming in the ongoing chapter itself, because the object which you have specified, let's say you have a Java Pozo. ठीक है, that Java Pozo is it works on the phone pay application, but the government APIs are written in let's say it runs in Python. ठीक है, तो it might not recognize that, so you have to use something which is recognizable by both the platforms. So we use something called JSON. ठीक है, there are other formats as well which will be discussed, but this is the basic thing, that you try to encode it to something which can be read by both the machines, both the services, to act together to serve the use case. ठीक है. And if we say that what we mean by this translation, so when we say you have one object which is in memory and then you are sending data over network, so you have something data structure, let's say hash map, and then you are converting it to JSON. This conversion is called encoding, and when you do the reverse, you decode this, like translate this JSON to again to hash map. This is called decoding. समझे बात? समझ गए ना? अब हम चलते हैं. यार ये बहुत वैसा हो रहा. जस्ट अ मिनट. यस, ठीक है, तो we mentioned that we encode the data, we decode the data. Now how you can do it? There are certain mechanisms which support this to do this. The first one is language specific encoding support. ठीक है, so there are languages, right? पता ही होगा आपको languages होती हैं. There is Java, Python, C++, C, Perl, lot of languages. So there are multiple libraries available inside the language which can be used for serialization, deserialization. When we say serialization, it basically means encoding. When we say deserialization, it basically means decoding. ठीक है, तो what you can use, let's say for example Java. In Java you can use java.io.serializable. In case of Python you have pickle, अचार. ठीक है. तो these are the internal libraries which can be used inside a particular programming language, but there are certain downsides of using a language specific serialization deserialization library. What are the downsides? First one is which is most important, encoded in Java will cause problems to decode in Python. ठीक है, आपने java.io.serializable से encode कर दिया and another service which you are hitting, let's say this is your phone पे application and this is your government APIs, यहाँ पे आपने java.io.serializable से encode कर दिया, it will not be possible to decode it in here pickle. ठीक है, so this will cause issues. You have to use something which can be identified by both of these services. So this is one problem. This is again lack of forward and backward compatible, the same reason, because it will be not be possible for both the applications to do that processing because they are unaware कि इसका conversion करना कैसे है. समझे बात? So to resolve this, to resolve the downsides, what we have some common formats which are industry specific and are used by multiple services and are read by the services logic. First one is JSON, then we have XML, then we have a lot of binary variants. If we specifically talk about JSON, XML, and then also CSV, first thing, like the downside which we discussed right now, that the support is specific to language. This will solve this problem. These formats will solve this problem, that this support for these is available across the languages. So the downside is solved. What are the some issues? First one is can't distinguish between number and string. So in case of JSON specifically, you can't identify because there is no data type specified. If we talk about JSON, this is how it is defined. ठीक है, जैसे name is Mandeep, and then Mandeep की एज है, कितने साल का है लड़का मनदीप? 18 साल का. ठीक है, तो if you talk about this particular number, right, you are not distinguish it if it's long, if it's integer, if it's string. You are not distinguish it, you are not differentiating it. So this is one downside. There is no support for binary strings, and there is a workaround using base64. If we talk about specific to these formats, there is no direct support available for binary strings. Then another downside is CSV don't have any schema, application defined meaning for each row and column. So you are not specifying any schema in case of CSV. ठीक है, CSV में क्या करते हो, आपने कुछ ऐसे वैल्यूज डाली, मनदीप कोमा 28 कोमा ABC कोमा जयपुर कोमा समथिंग. ठीक है, so what you are doing here, the application should identify what this first column means. After comma, this second column what it means, then third column what it means, then fourth column what it means. You are not specifying any schema beforehand कि what the first column represent, what the second column represent, what's the overall logic for my application. समझे बात? तो you don't have any application, you don't have any schema defined at run at CSV level which can identify what my data contains. Now you don't know what this first field mean. Mandeep कुछ नाम होगा, ठीक है, तो वी आर नॉट अवेयर ऑफ दैट बिफोर हैंड. सो यू हैव टू हैंडल दैट इन एप्लीकेशन इन केस ऑफ CSV. देन वी हैव बाइनरी एनकोडिंग. बाइनरी एनकोडिंग इज हेल्पफुल एज डेटा ग्रोज. ठीक है, जेसोन में आपका डेटा काफ़ी ग्रो हो जाएगा, XML में आपका XML इज लाइक अनदर लेवल. ठीक है, तो योर डेटा विल ग्रो इवेंचुअली. इफ़ यू हैव लार्ज डेटा सेट्स, योर डेटा विल ग्रो इवेंचुअली. सो इट्स बेटर to use binary encoding formats. Example could be for let's say for JSON, example are these bson, then bjson, etc. समझे बात? Then we have some another formats which you can use. Let's say one is Thrift, then we have protocol buffers, then we have Avro. So these will be discussing in short, ज़्यादा डिटेल में नहीं, kind of short. So if we talk about specifically about Thrift and protocol buffers, in both the cases you will define the schema that the data which you will be encoding. So unlike CSV, here you are defining the schema beforehand. Let's take an example of a person class. ठीक है, you have a person class and you have a username and what is the favorite number of that user. ठीक है, so let's say Mandeep, and Mandeep का favorite number 33. ठीक है, तो this you have defined, and also you have defined the tag numbers along with it. This is the important field in case of Thrift and protocol buffers, that each field which you are declaring here will be associated to a tag number. Let's say the first tag, first is the username, then second is favorite number, and also you are defining if it's required and optional. ठीक है, you will define if by required what we mean, that value will always be present. If it's not present, it should throw an error. By optional, what we mean, it could be null, or like we are not setting it anything. And if it's optional, then if we are not setting it anything, it will not throw an any error. Plus it is a runtime check. ठीक है, so if you like encode the data, it will not be reflected at that time, but when you actually read the data, there will be a runtime error that the data should be present but it's not present. It was a required field but it is null actually. ठीक है, तो थ्रो कर दो एरर, यूजर को बताओ कि भाई तुमने बोला था डेटा आएगा, स्कीमा में ऐसा बोला था तुमने, डेटा आ नहीं रहा, बड़ी दिक्कत की बात है, राइट? Moving forward, so Thrift had two binary encoding formats. One is binary protocol and there is compact protocol. Compact, जैसे आपको नाम से भी पता लग रहा होगा, it takes less space as compared to binary protocol. समझे बात? Now, moving to our important point from our chapter, कि how will your schema evolve? ठीक है, we are sure that schema will evolve. We discussed certain examples that as and when your application grows, as and when your features grow inside your application, your schema will is मतलब inevitable, होना ही है, वो इवॉल्व होना ही है. तो वी हैव टू एंश्योर कि वॉट एवर टेक्नोलॉजी वी आर यूजिंग, वॉट एवर फीचर्स वी आर यूजिंग, वॉट एवर स्टैक वी आर यूजिंग, इट शुड एंश्योर योर बैकवर्ड एंड फॉरवर्ड कंपेटिबिलिटी. एंड एज योर स्कीमा इवॉल्व्स, इट शुड बी हैंडल दैट देयर शुड बी मैकेनिज्म्स इन प्लेस जो ये हमें काम करके दे दे कि मैं एनकोड कर रहा हूँ, डिकोड कर रहा हूँ, एंड माई एप्लीकेशन शुड नॉट ब्रेक इन ऑल दो सिनेरियोज. समझे बात? So schema evolves over time, and how will you ensure encoding and decoding is backward and forward compatible? How can you do it? So in case of Thrift and protocol buffer, we mentioned that every field has associated tag number. ठीक है, this particular tag number, each field is associated to a tag number, and if a field is not set, it is skipped from record. Now, let's say you are changing some field names. What it will happen? The field tag should not be changed as they are used for encoding data. So it's okay if you change this field's name. Let's say जैसे ये user name है, इसको change करके मैंने name कर दिया, ठीक है? So it's okay if you change that, because our schema is not dependent on that. Our schema is dependent on this number. You should not change it if you want to ensure कि your application do not break. ठीक है, so the tag number should be kept intact to keep your application non breakable. अंग्रेजी खतरनाक हो रही है मेरी, right? ठीक है, तो दिस यू हैव टू एंश्योर दैट द फील्ड टैग नंबर्स शुड नॉट बी चेंज एज दे आर यूज्ड फॉर एनकोडिंग डेटा, एंड ईच न्यू फील्ड एडेड शुड बी गिवन ए न्यू टैग नंबर. नाउ वेन एवर यू आर स्पेसिफाइंग ए न्यू फील्ड, ठीक है, आपने लाइक यू हैव एडेड ए न्यू फील्ड फेवरेट नंबर यूजर नेम, देन यू ऑल्सो एडेड लेट्स से यू एडेड वन स्ट्रिंग residence place. So you will specify a new tag number 3 here. You will not specify the existing tag numbers. ठीक है, यहाँ पे 1 और 2 हमने define किया. This is very important in case of the schema definition for Thrift and protocol buffers. समझे बात? So if you talk about backward compatible and forward compatible, how your backward compatibility will be handled, it will ignore the fields which are newly added on read. ठीक है, so backward compatibility, it will whatever new fields you have added, your old code will ignore those fields, and your data type which you have specified will help. Let's say this is your data. ठीक है, तो यहाँ पे int था, it let's say it consume 2 bytes x y, then you have some array A, B, C, D. So if we know that this field is not present in our this field is some new field added in the new code. If my old code is reading it, I will skip this particular field. Okay, so I will skip this byte offset by reading the data type. This particular data type consumes my 8 bytes, so I will skip this and then I will read from here. Okay, this is how your backward compatibility will be handled. If we talk about forward compatible, what you have to ensure that a unique tab number is assigned to each field, and it will not cause any issues that we already discussed. If you are adding any new fields, then you are assigning a new tag number to it. It should not made required to avoid runtime errors. Why this is important? So if you are adding any new entry and if you have made it required, what will happen if my old code is reading it? If my old code is reading it and it is not present there, okay, if it's not present, then it will throw a runtime error and it will break. So we have to ensure that all the new fields which you are adding are not made required. What if we change the data type of existing fields? जैसे string था, this I have changed to long. So how will your data work? This generally is not a requirement. But it could be possible in certain scenarios. It's a very there are very less chances of these kind of requirements, but it could be possible, right? So let's say earlier you were using int 32, then you decided to move to int 64. Okay, these kind of requirement can come. There will be less chances that you are converting string to long, but these kind of scenarios can come. Okay, so what will happen? There is a possibility that let's say your data is written in int 64 and you are reading it in 34, then the extra data or like extra bytes can be truncated. समझे बात? क्योंकि वो इन 32 में it will not be possible to contain that much of data, sorry, which is written by int 64, and you can also lose precision. ठीक है, let's say in case of double, let's take an example of double. In case of double, let's say your value was 32.3245. Now if my new the old data type can only support this much of precision, but we increased precision in my new data type. ठीक है, तो the precision will be lost in case of older code. ठीक है, तो we have to ensure that for the time being the old data is served, or the new data is served for an older code. It handles that specifically in the application. Now moving to another format, which is Avro. ठीक है, we already discussed two formats. One is Thrift and another is protocol buffer. Talking about Avro is again your binary. Avro is again your binary encoded format. It also specifies schema, like we use schema in case of Thrift and protocol buffer. It also uses schema to specify structure for data to be encoded. This is and there are no tag numbers. In case of Avro, you don't have to create the tag number specifically to identify the fields. ठीक है? In case of Thrift and protocol buffer, the tag number concept was very important because it was used to identify कि कौन क्या है. ठीक है, फील्ड नंबर 1 है तो इसका ये है, फील्ड नंबर 2 है तो इसका वो एट्रीब्यूट ये है. तो यू हैव टू स्पेसिफाई दैट इन केस ऑफ थ्रिफ्ट एंड प्रोटोकॉल बफर, बट in case of Avro you don't have to worry about that. So if we talk about specific example, the person class only, you will define that we have string username, then you have, let's say, interests, or the same which we specified here. What was that? It was favorite number. ठीक है, but you are not specifying that tag numbers here. Now the one most interesting thing is another interesting thing is, like first one is that you don't have to specify the tag numbers. Another one is it is the most compact as compared to others. ठीक है, so it will take the minimum possible space as compared to your protocol buffer and Thrift and any of those JSON, XML and all those. ठीक है, now Avro defines schema in terms of writer schema and reader schema. ठीक है, तो Avro की अगर like if we talk about schema, there will be two clients, right? One who is writing the data and one who is reading the data. This is your reader and this is your writer. So the schema which is written by a writer is called writer schema, and the schema which is read by a reader is called reader's schema. समझे बात? Now you have to ensure that the whatever data you have, whatever application you have is backward compatible and forward compatible for both of these reader schema and writer schema. Now how you will ensure that it will work. You have to ensure that both of the reader and writer schema is compatible. Let's take some examples on how you can ensure that it should be compatible, and it is compatible and it is not breaking. Let's say you add or remove any values. Field should have default value. So let's say you added a new value. Okay, you added a new column. You earlier have two columns, C1 and C2. You introduce C3 new column. Now if this application is read by a older code, it is not expecting this data. Okay, so you can introduce some new uh, default value here. Let's say this data is read by a newer code. ठीक है, so for entries older than t1 timestamp, ठीक है, कि मैंने आज 12 बजे नई fields ऐड करी है, नए columns ऐड किए हैं. What about the data which is older than 12 p.m. 12 a.m. whatever the date is. ठीक है, तो how will you handle that? So when you specify this new column, you will specify that the data which is older than 12 p.m. this will have a default value return, let's say null या फिर empty string. ठीक है, तो this is a possible scenario which you will have to handle, which first you will specify in your database or like whatever format you are maintaining, and then whenever you read that in your application, you have to ensure that whenever a default value is written, it should be handled appropriately. Apart from that, you will maintain a version number as schema evolves. ठीक है, so let's say earlier it was v1 schema, then you added a new column c3, then it was v2. Again, like it will depend from architecture to architecture, but also you can define that major and minor versions. Let's say you were the changes you specified were very minimal, then you can specify version 2.1, 2.2. If there was a major change, then you can specify version 3. ठीक है. Another important point in case of Avro is it has dynamically generated schema. ठीक है, how it helps, you don't have to worry about tag numbers. Unlike Thrift, the schema can be generated from your object schema. So whatever object you have created, the schema can be generated from that. ठीक है, समझे बात? डायनेमिक का मतलब रन टाइम पे ये काम हो रहा है. So we have discussed different kind of formats to encode and decode data. What about data flow? So data will flow from one place to another place. How will you ensure it is backward compatible and forward compatible in each of these scenarios? So let's say there is a data flow across the databases. ठीक है, so how will you ensure that? And if we already discussed that your code is inevitable, your data is inevitable, and it will change as your data grows, as your feature grows, as your application grows, as your user base grows, everything grows in your system. It will change and the data will keep on evolving. ठीक है, तो database will change over time. Example, you are adding a new columns to RDBMS. ठीक है, the same example we discussed earlier, we had C1 and C2 columns, then you introduce a new column C3. ठीक है, तो it could be a possibility. Now what you can do, the same example we discussed about that, right? You can specify default values in case of newly introduced columns, and it can be held in your application code as per requirements. ठीक है, application can specify the logic that if a default value is coming, then this is how you handle it. If there is no value coming, this is how you handle it. So you can specify all those logic in your application code, and accordingly it can work on it. Apart from that, it is a good choice to compare it a good choice as compared to migrating entire DB to new schema. So this specifically that you specify a default value. ठीक है, there are two options here. One is you have database here db1, and you introduce a new columns. ठीक है, you earlier had c1 and c2, and you introduce a new column c3. Now you have two two options. ठीक है, what you can do in this same database, what you have added c3 and you added some default value. ठीक है, other option is you keep this data intact and move this entire data, ठीक है, to here, and introduce a new column here. It will be a painful process. Why? It will be a painful process because you have to migrate the data from one cluster to another. So there is a possibility of downtime which you have to specifically handle. In a case of RDBMS, it is again a very pain point to migrate the data. And whenever you are adding new columns, it is again a pain point because you have to ensure that there is a no downtime in your application, and that we have to ensure as well, right? Whenever we launch our application, we have to ensure whatever happens in backend, it is always available to the customers. The chapter 1 which we discussed. एप्लीकेशन के बैकएंड में कुछ भी चल रहा हो, फॉर फ्रंट फेसिंग कस्टमर्स माय एप्लीकेशन इज ऑलवेज अवेलेबल टू सर्व देम। ठीक है, मैंने बोला है कि दिस इज द फीचर आई प्रॉमिस्ड एंड आई विल सर्व दिस फीचर टू यू वट एवर हैपन्स इन माई बैकएंड सिस्टम। डेटा सेंटर उठ गया, मैंने डेटा का स्कीमा चेंज कर दिया, वट एवर हैपन्स इन द बैकएंड आई विल कीप ऑन सर्विंग द कस्टमर्स। ठीक है, तो दैट यू हैव टू एंश्योर टू नॉट ब्रेक द ट्रस्ट ऑफ द कस्टमर्स विच दे बिलीव्ड ऑन यू कि भाई मैं कैब बुक करना हूँ, मैं फंक्शनैलिटी दे रहा हूँ टू बुक द कैब्स, टू प्रोवाइड द फंक्शनैलिटी ऑफ कैब शेयरिंग फीचर। ठीक है, ठीक है, तो you are ensuring that, and that's how you build your application. As and when your application grows, you have to ensure that it is backward and forward compatible. What about that there is if there is a data flow among the services? ठीक है, the example which we discussed, that phone pay is doing something and then it is reaching out to government APIs to complete the transaction. ठीक है, so there is an interaction between services. One service is running on this cloud, one service is running on another cloud. There is a network call in between, बीच में इंटरनेट है यहाँ पे, ये रहा। ठीक है, ये इंटरनेट है यहाँ पे, तो यू आर योर दिस इज योर पर्टिकुलर, लेट्स से दिस इज योर फोन पे एप्लीकेशन एंड दिस इज योर गवर्नमेंट एंड पॉइंट। ठीक है, दिस इज योर गवर्नमेंट एंड पॉइंट, सो द interaction will happen over internet and you have to ensure that any changes in them or like how they are interacting, you have to ensure that it's working. That's our end goal. Whenever we design distributed system, that's our end goal, कि our application is always operational, it's always available. So there are two mechanisms to do that. One is rest is basically a architecture pattern, or like you can say a paradigm which is built over HTTP, where you use the HTTP methods only to specify your APIs. Let's say get API, and then you define your structure. Let's say get my list of restaurants, or let's say banks. ठीक है, my user ID is this and my location is this. So this is like kind of one basic schema, and another is one XML based protocol which is again used for network API calls these days. SOAP is very less preferred and is very less used. REST is the one paradigm which is used extensively among the service interactions. ठीक है, one other mechanism which we will discuss is RPC. RPC basically means remote procedure call. So whenever you are trying to access a remote server, okay, there is one place here, one machine here, another machine there, you will have to interact over internet to interact with that machine. So it will happen by RPC. One example is gRPC. In this video, we are not specifically deep diving into the complete details, but one possible way of RPC is gRPC, which supports streams as well. Call consists of series of request and response over time. ठीक, समझे बात? Another thing is data evolution. ठीक है, how whenever the data evolution happens on your network calls, how will you handle it? So server will be updated first and then clients. ठीक है, let's say if we talk about the server and client architecture, ठीक है, what will happen? Your client will make request to server and then server will return the response. What if there is any update in your API? So first your server will be updated, ठीक है, and then you have to ensure that clients are updated to handle that. So you have to ensure that there is a backward compatible for request and there is forward compatibility for response. This diagram will clear it out. So first you updated the server and then you like this is your initial system. ठीक है, it is working fine. Now you are updating the schema, API schema to v2 or the data model to v2. ठीक है, तो you will update the server logic नहीं, update the architecture on your server, so that architecture भी नहीं यार, update the structure basically, ठीक है, of the API which you are API which we are talking about, or the data model we are talking about. ठीक है, you will update it on the server, and your request which is coming for clients is only still old. ठीक है, you are not expecting the newer pattern to come or newer request parameters to come, so your server should be able to handle it. Now once your client updates it, you have to ensure that it will be a possibility that all clients have not made all the changes, so your client can come with older request or newer requests. So you have to ensure that the response you are returning is forward compatible. समझ गए बात. अनदर थिंग इज मैसेज पासिंग. ठीक है, द एसिंक्रोनस मैसेजिंग, लाइक द two protocols we discussed. One is like rest and soap, where you are making synchronous calls. ठीक है, synchronous call कर रहे हैं हम, that you are sending a request and then you are getting the response. But in case of message passing, what happens, you send the request but you don't expect a response. ठीक है, how it works, you will this is your, let's say, server one, it could be a client, whatever terminology we are using. Let's say it will publish a request here, we will have a message broker in between, it will store the request here. ठीक है, let's say you got one message, it will store the message here, then whatever are the subscribers of that particular topic. So we have specified multiple topics here. There is a specific video created on asynchronous processing in our system design playlist, you can refer that, we have complete details captured there. तो काफ़ी अच्छे से समझ में आएगा. But to get gist of it, what will happen, you will store that message for a time being, and whatever subscribers for that topic are, ठीक है, the request will be published to a particular topic on this message broker, and whatever subscribers we have, this can be like let's say you have server 2, then you have server 3, all the servers which we will have, it will be forwarded to the request, the message will be forwarded to all the servers which are subscribed to that particular topic. ठीक है, तो the message broker will provide a temporary storage which can store message for some time if refuser is not available. This also makes our system reliable, right? If the server 2 is not available for a time being, then it will keep the message here, and once the server 2 is available, then it will deliver that. Another thing is receiver server can consume message on its own rate. So it could be possible that the server one is publishing the messages in burst rate, but these servers don't have to consume at that same rate. They can specify in configurations कि मेरे को इस rate से messages आने चाहिए. So they can do that. ठीक है, and it's easier for them to maintain that load, so that the hardware basically don't break. ठीक है, अगर मैं TPS 10 का सपोर्ट कर पाता हूँ, then I will not be able to handle the burst traffic of 100, right? It is a 10x increase. I will not be able to handle it. So I will specifically define in my configurations that I only consume 10 messages per time. They will be held here for the time being, but once the 10 messages are consumed, then I will poll for more. One message can be sent to multiple receivers, that we already discussed, that the server one, this particular server is publishing the notification to, publishing the particular message to a particular topic. Now whatever subscribers we have for that particular topic, it will be published to all of them. Sender doesn't wait for message to be delivered to receiver. This we already discussed. This is what we mean by asynchronous specifically. ठीक है, कि मैंने मैसेज भेज दिया, मेरे को फ़र्क नहीं पड़ता उसके साथ क्या हो रहा है, मैंने अपना काम कर दिया, तुम आगे का देखो. समझ गए बात? तो if we talk about examples, we have Kafka, RabbitMQ, Amazon SQS and SNS combination. So these all you can use. There are other frameworks as well, other technologies as well. Let's say one is Celery. ठीक है, तो there are available. You can use any one of them as per your use case. There are certain downsides, certain benefits associated to each of them. They can be chosen as per your use case. The final topic of our today discussion is actor framework. It is specifically used in Erlang OTP, or like in case of concurrency managements. Let's say if we talk about single example, one example, let's say the chat messaging. ठीक है, WhatsApp. So WhatsApp in backend uses 𝐂𝐸𝐴𝐷, which use actor model. You will have multiple connections open, so they are handled by actors. ठीक है, so what we mean by actors is, actors are running a single process which interact with each other to do the work. ठीक है, तो it's a programming model for concurrency in a single process. Each actor represents one client. There are multiple clients, so each process, let's say you have 10 process. Now each process can have, let's say, 10 actors. They will handle 10 clients. ठीक है, 10 connections. So let's say your users are connected, user A, B, so it will be handled by A1, ठीक है, actor 1. Then you have C to D. In this process only, it will be handled by A2. समझ गए ना बात? ये C और ये D. ठीक है. So actors communicate with each other by sending messages. There could be a possibility or there could be a requirement that actors need to interact with each other. ठीक है. So they will interact with each other by sending messages to each other asynchronously, and we also don't provide the guarantee that message will be delivered. There could be possibility that message is dropped and we are fine with it. ठीक है. तो we are fine with that. Let's take one example. ठीक है. So a live streaming video. ठीक है. In live streaming video is running and people are posting the reactions. ठीक है. मैंने हार्ट भेजा, मैंने लाइक भेजा. लाइक कैसे भेजते हैं? ऐसे थंब वाला. ठीक है. मैंने कुछ और भेजा. क्या भेजा मैंने? ये भेजा हमने. ठीक है. तो द रिएक्शंस यू आर सेंडिंग, इट कुड बी पॉसिबल दैट ए पर्टिकुलर रिएक्शन इज ड्रॉप्ड एंड वी आर फाइन विद इट. ठीक है. 1000 में से एक ड्रॉप हो गया, वी आर फाइन विद इट. सो दिस इज द बेसिक पैराडाइम. सो Erlang OTP इज वन एग्जाम्पल. अनदर वन इज एक का बोलते हैं जिसको. ठीक है. सो ये यहाँ पे लिखा हुआ है. तो these all are the some examples for actor framework. So this is all we are going to discuss today. We will meet again in our next video where we will be discussing chapter 5 or anything else. We will see what we come up with next. Till then, stay safe. Tata. Bye bye.